To get the full course, visit www.zdub.com. Hello everyone, welcome to the data science tutorials. These tutorials are brought to you by ZDub Technologies and Services. This tutorial course is designed specifically for the beginners, and this course is designed so that even if you are an absolute beginner and have no knowledge about data science, then also you can proceed with it and would be able to understand that what this field is, how can you just make use of the knowledge given in this course and apply it into your professional career. So let us start with this tutorial. And you must be wondering why we have taken up this data science, or why should we take this data science course. So data science is one of the most demanding job of the 21st century. Each and every organization all around the world is looking for the people who have good knowledge of data science. In this tutorial, we are going to give you everything. We are going to introduce you to the concept of data science, theory, then practical. We will tell you about the different tools, the different components, different applications, and the different job roles in which you can prepare yourself for. Also, we will discuss what is data science, why do we need it, what are the prerequisites, what are the different tools, how can you solve problems with data science, and what domains are where the applications of data science could be found. So let us start with this tutorial. And the first question is, what is data science? So as I just said, this course is designed for absolute beginners. Even if you are a beginner and have no knowledge of data science, then also you can just proceed with this course, because as you can see, we are covering everything from the basics. Data science is actually a study of data. So what do the data scientists do? They just study the data, try to find out the patterns, meaningful insights, or some kind of information from the data, and using that particular information, they try to predict something. For example, you might have noticed that during the COVID-19 pandemic, there were different reports that by this time, these number of the cases would be reported every day in this country. There were all these wild guesses, right? So this is all because of the data science. A simple example is that suppose we are having the data for the month of March 2020, the everyday data of our country, India. Then we are having the data that in which day how many cases of COVID-19 were reported. Then what did the scientists do? They just collect this information from various sources. They just study the patterns in the data. They just try to analyze the data, and then with the help of this data, they try to predict the future results. That is why there were several reports claiming that by this time, or by the month of April 2020, or by the month of September 2020, India will reach its peak in the coronavirus cases. So this was all possible because of data science. Now you must be wondering, that is a very lengthy process. Yeah, data science is something that requires a lot of patience, but there are different tools available through which you can easily just perform the analysis part, or you can easily just analyze the data for the different insights. So the knowledge of these tools is necessary because it is a multidisciplinary field. It uses the most powerful hardware, programming systems, and the algorithms to solve the data related problems. It is the future of artificial intelligence and employs the knowledge of machine learning as well. So in short, we can see that data science is about taking a look at the data and asking the correct questions. Like, you have data presented to you, so you don't know what to do with that data. This is exactly what data science allows us to do. With proper practice, whenever you are trying to say a data set, you would be able to raise some questions, and when you try to find the answers of those questions based upon a particular procedure, then that whole procedure is known as data science. Now why do we need data science? So these are the few places or the few ways in which data science is needed. For route planning, that is, if you have used the application, there is one popular application called Google Maps. So what is the task of Google Maps? Google Maps just takes your destination and your present location, and on the basis of that, traffic, the weather, and your vehicle, it just gives you a route. So this is an application of data science. That means it requires some variables or some data. That is, what is your starting location, what is your destination, and what kind of vehicle you are using. Like if you're using a bike or a two-wheeler, then it may take a different route than when you are using a four-wheeler or you want to use a public transport. Apart from this, it also takes into account the traffic. That is why whenever your route is highlighted, you get to see some of the red and the blue patches. So this is route planning, for which data science can be used. Another application is for predictive analysis. Now, what is predictive analysis? An example of predictive analysis is actually the prediction of the COVID-19 cases that we just understood previously. So that could be in predictive analysis. That is, whenever you use some data to predict the trends for the future, that is known as predictive analysis, or to make some prediction. Third application is to create promotional offers. This is very much important for the e-commerce industry. You might have seen that different e-commerce websites just produce different kinds of promotional offers, right? Right now in India, we are just going for vocal for local. That is why these promotional offers are now concentrating themselves to the Make in India products, right? So this is what data science tells us. Based upon the patterns that what kind of products the customers are liking in the past, the e-commerce companies are prompted to predict or create the promotional offers customizable for their customers. Its example, you can see that once you buy anything online, you get recommendations related to that product. So this is where data science application is found. To forecast the revenue of a company. Now this is very much related to the predictive analysis only, because here also we are just trying to understand the assets and the liabilities and the stocks and all the values of the company that it has gained in the past, and on the basis of that, it is used to predict the revenue of a particular company in the future. Now another application of this could be to predict the price of the stocks or the trades through which we can just invest our money. So for that purpose also, a good knowledge of data science is considered very necessary. To analyze the health benefits of training. Now this application is also very common, as you can see in many of the fitness devices such as Fitbands, etc., where it takes your daily data. That is, how many calories you burn a day, how many steps you walk, or how many kilometers you walk, or what activities you do, and on the basis of that activity, it just maps the training procedure. Like there are applications actually that help you to reach a particular goal, such as you want to reduce your blood sugar level or you want to just lose weight. Then on the basis of your set goal, it predicts you or it provides you with a training pattern. So this is where data science can also be used. It takes some data such as your past experiences, your current specifications like weight, height, cholesterol levels, sugar level, etc., and on the basis of that, it gives you a training pattern. Next is to predict the possibility of events. Now there are many events whose possibility, if you want, you can predict, like whether a particular event will occur or not. A very common example we can take that if you visit a website such as website that is selling something, or you are trying to bid for something, right? If you are just trying to register in an auction, then there is a possibility that you will bid for that particular item or you will not bid for that particular item. So this is a possibility of an event that could also be predicted with the help of data science. So these are some of the applications of data science. These are some of the places where data science is needed, but they are just a trailer, because there are immense possibilities of data science and there are immense applications of data science. My sole purpose over here is to try to make you aware of the fact that we are using already data science in our day-to-day lives, and its usage is going to increase day by day. So if you are planning to just go with this course, then it is a very good decision and you should proceed with it. That's all for this video. In the next video, we will try to go deeper into the understanding of data science. Thanks for watching. Hello everyone, welcome back to the data science tutorials. These tutorials are brought to you by ZDUP Technologies and Services. In this video, we are going to learn about the process of how a data scientist works. So the data science, as we have understood, is a procedure or is a job in which the data is analyzed. It is taken into account to predict some patterns, to answer some questions, or to solve some problems. So this is the whole thing that a data scientist needs to do. Only input he has got is of the data. From the data, he first needs to know that what are the questions that he must ask. Once the questions have been formulated, then on the basis of the data, the answers needs to be found. So for this process, the multidisciplinaries are required, as we have discussed that data science is a multidisciplinary field. The first field that we require is machine learning. Why machine learning is required? So what happens in data science is, once you have got the data, once you have analyzed the data and understood the patterns from the data, then you need to feed that data into your machines so that the machines could just predict the pattern of that data, right? If you want to form a predictive analysis, or if you just want to gain future insights into anything, then you need to develop a machine learning model. So whatever the past data is present, you need to just give it as a training data, and on the basis of that, once your model is trained enough, it would be able to predict the new results. Second discipline is required is statistics that are used to gain useful insights into the data, such as if we have some numerical data, so how is that data distributed? What are the different outliers? What is the range of the data? What is the standard deviation? What is the variance? What is the mean, median, mode, etc.? Some programming knowledge is required as well. So as far as the data science field is concerned, Python or R are the two programming languages that you should have an understanding of. In this tutorial, we would be concerning ourselves with Python, because Python has these different libraries that are useful in just creating the process of data science very easy, or making the process easy. Then a basic knowledge of mathematics is also required, because there are some machine learning algorithms like the linear regression where we use a very simple formula of the mathematics, and that is the slope of the line. If you remember, y equals to mx plus c. So this is the formula that we use in linear regression. Apart from this, there are different applications of mathematics as well that you would be seeing in data science. Databases are required because data science works on data, right? So when you are working with data, you might need some way to store that data, to organize that data, and that is why databases are required. All these disciplines or these different fields require the different tools, so we will be discussing about that as well. But for now, we would be discussing the process of formulating or process of conducting this data, or how can we just work with this data. So the first step is to ask the right questions, right? Suppose you have a data set in front of you, and it is containing the daily reports of the COVID-19 cases in India for the month of March 2020, right? So you are having a state-wise representation. There will be all the states mentioned and the total number of cases from that particular state on that particular day. So this is a daily report, right? So you can ask the question based upon that data that okay, which state is giving me the most number of cases, which state is giving me the least number of cases, in which state the cases are increasing, in which states the cases are decreasing, everything. All these questions you can ask, but for that first you need to look at the data, because if your data is not present, you don't know how your data is going to look, you cannot formulate the questions that you are going to ask. Second process is to explore and collect the data. Now what does this mean? This means that once you have insight on the data, then you might work to just collect more data upon that particular insight. If we have daily report, if we have a report of one day, on the basis of that we can formulate our questions, right? Now if you just want to answer the question that in which states the cases are increasing, so for that particular question you won't be requiring just the data of a single day. You at least need data for a fortnight or for a week to answer that particular question, right? So on the basis of the questions, you have to explore more and collect more data that is relevant to your findings. Then you need to extract the data. What does this mean? It means that data is present in the various formats, right? Very common is the CSV file format, that is the comma separated values format, but it is just like a perfect data set which is never available in the real world. In the real world, the data that you get is scattered all over the place. It could be in the form of a web page, it could be the form of you can say an Excel sheet, it could be stored in a PDF, it could be in different formats. So your step is to just extract the data from all those different sources, to scrape the data from those different sources and bring it to a common platform. Then after bringing the data, you need to clean the data, because it is highly possible that the data that you have got from different places, it is unclean, that it can contain some kind of discrepancies. So you need to remove those discrepancies and basically just prepare the data so that some kind of analysis or predictions could be made on it. Then if you have any kind of missing values, you must find a way on how to find and replace those missing values, right? So there are these different methods, different steps that you must keep in mind while even replacing the values, because there is no standard method which you can apply at every place. There are few things that you must consider into your mind. Depending upon the nature of the data, the nature of the questions you are asking, the nature of your findings, or what analysis you're trying to do, that what kind of values you can replace. Okay. Then you need to normalize the data, means to convert it in a format such that the models could be based upon that, such that the predictive analysis could be performed on that data and the patterns on that data could be found. The final step after this is to analyze the data, to just find any kind of patterns and to make future predictions. These steps include the formulation of the machine learning algorithm, that is what algorithm you're gonna just use on the data, and how your data is going to fit that particular algorithm, dealing with the outliers, creating models, training models, and predicting the results. Once results have been predicted, you need to represent the result in the different kinds of formats, such as bar graphs, plots, scatter plots, and line charts, anything that you deem necessary for your data. So this is the whole process of creating or analyzing the data from the perspective of a data scientist. All these steps, these 8 steps, that is from 1 to 8, needs to be followed. Then only you would be able to get the particular result for that data or a particular prediction on the basis of your data. So this is the whole process that you must follow. Now next is the type of the data science job. So once you have learned data science, then what are the different opportunities that you would be presented with? These opportunities are data scientist, data analyst, machine learning expert, data engineer, data architect, data administrator, business analyst, or business intelligence manager. Now, these are some of the job titles that you can adopt after learning data science, but all these different job titles are different from one another and require the different kinds of skill sets. So what are the skill sets required for each of these jobs? This we will take a look in the later video. This is all for this video, in which we learned the whole process of data science. So thanks for watching the video. Hello everyone, welcome back to the data science tutorials. These tutorials are brought to you by Untitled Technologies and Services. In this video, basically, we are going to see some of the popular data science jobs and what skill sets are required. Then we will proceed with the basics of data science, right? So first of all, we will talk about data scientist. So data scientist is actually a person who works with data and gives some insights or comes up with insights that could be generated from that data, and is involved in the designing of the different algorithms or the adoption of the different methodologies to just work with that data. The skills required for data science are the technical language skills such as SQL, Python, Hive, Apache Spark, MATLAB, etc. The data scientists must have the understanding of statistics, mathematics, visualization, and the communication skills. Now, data analyst is another job that you can go for after learning data science. Data analyst also works with a huge amount of data, models the data, and looks for the relationships and the trends in data. At the end of the day, the work of the data analyst is to come up with a visualization to report and analyze the data. So any kind of visualization through which the data scientist could just take a look at the data in a good way, in a very, you can say, concise way, is the job of data analyst. The jobs or the skills required are mathematics, business intelligence, data mining, and basic knowledge of statistics. Machine learning expert is someone who just works with these different kinds of machine learning algorithms so that he can come up with the best algorithm depending upon the data. The different algorithms such as regression, clustering, classification, decision tree, k nearest neighbor, etc. can be used. So the skills required are a good understanding of the machine learning and the knowledge of the programming languages like Python, Java, Hadoop, R, etc. Then we have data engineer. He is someone who works with the data and is responsible for maintaining the data architecture for the project of the data science. He works with the creation of data set processes that is used in the fields of modeling, mining, acquisition, and verification. Thus, a data engineer who usually interacts with the data must have the knowledge of the database such as SQL, MongoDB, Cassandra, Apache, Spark, Hive, Python, etc. Now let us understand what are the prerequisites for data science. If we talk about the non-technical prerequisites, we have three non-technical prerequisites. The first one is curiosity. To learn data science, this is the must-have requirement in a person. You must be curious enough to just take a look at the data and ask the questions, and you must have that knack in you to solve those questions, to find out those answers of those questions. Only then you would be able to become a good data scientist. Apart from this, critical thinking is also required for data science so that you can find multiple new ways to solve that particular problem. Communication skills are required. They are actually one of the most important skills for a data scientist, because after solving a problem or after finding the solution of a particular problem that has been given to you, you need to just communicate those solutions to the higher management bodies and vice versa, right? So this is what three of the most important non-technical skills are required in a data scientist. If we talk about the technical skills, so first is computer programming. You must have some basic knowledge of the programming languages such as R, Python, Spark, etc. Because without this, you won't be able to write any code or to work with your data. In this particular course, a requirement is a basic knowledge of Python. So I hope that you all have a basic knowledge of Python, because then only you would be able to proceed with this course. Second is machine learning. To understand data science, we need to understand the concept of machine learning, because machine learning algorithms are used to solve various problems. However, for this course, if you don't have any knowledge of machine learning, then also you don't need to worry, because I will be covering machine learning from scratch. Statistics includes the basic understanding of the fields of statistics and mathematics, such as mean, median, mode, standard deviation, variance, etc. So just the basic knowledge is enough. Then if we talk about databases, the understanding of the databases such as SQL is essential to work with data, because you must know that how the data is organized, or what is data, how can we just work with the data, then only you would be able to just clean up your data or understand about it. Then last but not the least, mathematical modeling, which is required to actually make the mathematical calculations and the predictions faster. If you have some tricks up your sleeve, then they're definitely gonna help you. But even if you don't have that much understanding, a basic understanding would be fine, because there would be some terms that I would be using throughout this course that you would be able to understand it easily if you have a background of mathematics. Now, if we talk about the different components of data science, so let us just start with the basic concepts of mathematics, right? So basically there are 7 components. Let us start with mathematics. Mathematics is the critical part of data science that allows us to just understand the different things that are going on with our data. Many of the machine learning algorithms are actually based upon the mathematical concepts. Machine learning itself is the backbone of data science. It is all about to just provide the training to the machine based upon the past data and use that training to just predict the pattern for the future. Then we have computer science. Computer science basically refers to the knowledge of you can say the programming languages such as Python, R, Spark, etc. that helps you to develop a logical thinking approach through which you can just formulate what step to do next with working with the data. Then we have domain expertise. So domain expertise basically binds data science together. It means the specialized knowledge or the skills of a particular area. Like if you're just trying to work with any kind of you can say data, you must have some knowledge on that particular data. Then what you would be able to do is you would be able to better understand the data. Like if you're trying to predict the presence of the COVID in a particular patient, if you are just taking a look at his vitals and if you're trying to predict that whether he would be affected by COVID-19 or not. So in that kind of thing, you must be someone with a domain knowledge of that medical history, or you must have some knowledge about that particular field. Then only you would be able to predict it, or you would be able to better understand the data. Then we have statistics or statistical research. It is one of the very important components of data science. Through statistics, we can collect and analyze the numerical data and gain meaningful insights from it. Then we have visualization as well. It is meant by representing the data in the visual context so that the different insights could be drawn from the data, the significance of the data could be understood. Data processing is how you are going to process the data for the end user. Now, Last but not the least, we have some of the tools that would be used for data science. There are these different categories of the tools. If we talk about data analysis, the different tools are R, Python, statistics, SAS, Jupyter, RStudio, MATLAB, Excel, and RapidMiner. Data warehousing is the collection of the data. How can we collect the data? How can we store the data? For that, we have ETL, SQL, Hadoop, etc. Data visualization tools helps us to plot the different kinds of charts and graphs so that we can visualize and understand about the data. These includes R, Jupyter, Tableau, Cognos, and Power BI. Machine learning tools help us to just create and use those machine learning algorithms on the data, which include Spark, Manhout, Azure, ML Studio, etc. Now, what is the data science life cycle, or how the things go in the field of data science? This is something that we will see in the next video. Hello everyone, welcome back to the data science tutorials. These tutorials are brought to you by ZDUP Technologies and Services. In this video, first of all, we are going to take a look at the life cycle of data science. So this is the diagram for the data science life cycle. Let us start with understanding it, right? So the first step, or the first process, is the process of discovery. This is the first phase of the data science life cycle, which involves asking the right questions. Which means if you just want to ask some kind of questions, so this is the phase that you should go for it. This is the phase where you're gonna ask the questions. When you start any project, you need to determine that what are your requirements, why are you starting this project, and what is the end goal. That is, what are you planning to get from this project once it is completed. So this is the phase where we determine all the requirements of the project, such as how many people are required, what is the technology that we are going to use, how much time is required, what is the data that we are going to use, what is the data set we are going to use, what are the different sources from where we are going to get the data, and what is our end goal. So all these questions needs to be answered in the discovery phase of the data science life cycle. Once all these questions have been answered, then we can just frame the database, the business problem on the hypothesis level. That is, we can just formulate a hypothesis, because once we have formulated a hypothesis, then we can use data to answer that whether that hypothesis was correct or not. The second phase is the data preparation phase. This is the second phase. It is also known as data munging phase. We need to perform the different tasks in the data preparation phase. Actually, there are these 4 tasks that we are going to perform. The first one is the data cleaning, then data reduction, data integration, and data transformation. So we have cleaning, that is, we need to clean the data from just remove the unwanted data that we have got from various sources. Then we need to reduce the data into a format that is helpful for us to understand it and work with it. Then we need to integrate the data from the different sources into a common format. And then we need to transform the data so that it becomes useful for us to work with that particular data. After performing all these steps, we can move on to our next phase, and that is the model planning phase, or the model planning stage. In this stage, what we do is we have these different methods and techniques. These are what we just devise to establish a relationship between the different variables that we have. Now, what are variables? Actually, when we get a data, we just treat all the different attributes or the different columns that we have as variables. So we just take those variables and try to find out the relation between them. Then exploratory data analysis is used to just explore more about the data. And the tools that are used in this phase include the SQL analysis service that is used. Apart from this, some of the programming languages such as Python or R can also be used. So Python or R. right? After we have planned the model, we need to start working on that model. So the next phase that comes is known as the model building phase. In this phase, what happens is the process of model building starts. That is, we create the data sets, one for training. So we try to split or create the data set for training and for testing purposes. So for two things, these data sets are created, that is for training and testing purposes. Now once the data set have been created, we just need to know that what data set we are going to use for training the model and what data set we are going to use to test that particular model. We apply different techniques such as association, classification, clustering, etc. to build the model. So it is in this phase that we select which model we are just gonna use basically. So after being selecting the model, we just try to apply our model on the data set. And the tools that we're going to use include the SAS, Enterprise Miner, Weka or MATLAB. The fifth phase is operationalize. In this phase, actually, the final reports of the project are delivered. So it is used for the report generation. It is the report generation phase. Actually, the reports are generated, any kind of briefings you have, any kind of documents you have. So basically all the paperwork is done in this phase. That means after using your model in the previous stage, that is in this model building phase, we have predicted something. So in this phase, or between this fourth and fifth phase, we just try to document our findings and predictions and what is the overall requirement or overall findings that we have got from our project. This is where it is documented in this phase, that is operationalize phase. We get a clear overview of the complete project performance and whether we were able to answer the questions or not that we got from the discovery phase. Then the final phase is the communication of the results. Once you have got your results, you need to check that results, or you need to give those results to the management. So it is done in this phase, that is the result communication occurs in this stage where the final results are being communicated to the management, and whatever the findings are, those findings are given to the team so that they could work on that particular data. So this is the whole life cycle of data science. That is how you're gonna work with data science, right? So that is all we need to know about the prerequisites of data science, or how can we work with data science. Now we are gonna start. Basically, first of all, what we will do is we will just try to understand the different Python libraries that we have, and what will those libraries do. They will just help us to perform our different tasks. Okay, so first of all, let us take a look at what libraries we are gonna learn. So these are the some Python libraries that can be used for data science. So if we just take a look at them, we have libraries like numpy. So numpy is basically a library that helps you to deal with the arrays, right? There is no way in which we can deal with arrays generally in Python. So for this, we are going to use this numpy library that helps you to just work with the different machine learning and deep learning applications. It stands for numerical Python. Next we have is SciPy, that is scientific Python. That is the go-to library that you can use whenever you want to compute anything scientifically, and it is used heavily in the field of mathematics. Beautiful Soup is another library that helps you to enable web scraping from HTML and XML documents. Scrapy is a Python framework for large-scale web scraping. Pandas is the data exploration library and data visualization library. It can also be used for data analysis. Matplotlib is one of the most popular library of Python that is used for data visualization to plot the different types of charts and the graphs, etc. Plotly is again a free and open source data visualization library for Python. Seaborn is again another free and open source data visualization library. It is based on Matplotlib. Scikit-learn is the indispensable tool in data science that will help in the making of the machine learning models. Iterate is an open source machine learning library that helps from data preparation to model deployment. TensorFlow is developed by Google Brain team, and it is basically used for deep learning. Keras is another deep learning API that is written in Python, which runs on the top of the machine learning platform TensorFlow. Last but not the least, we have PyTorch, which is considered one of the best deep learning frameworks in Python. So in this tutorial, we would be working mainly with NumPy, SciPy, Pandas, Matplotlib, Seaborn, and Scikit-learn. So that's all for this video. And that's all for the basics of data science. From the next video onwards, we would be starting with the basics of the NumPy library. So thanks for watching the video. Hello everyone, welcome back to the data science tutorials. These tutorials are brought to you by Untitled Technologies and Services. From this video onwards, we are going to understand the Python code for practicing the data science concepts. So as we know that there are multiple Python libraries that could be used for the different steps in the data science procedure. So from this video onwards, we will be starting the NumPy library. So to run that NumPy library, we need to write a corresponding Python code, and that Python code we are going to write in our AWS Cloud9 IDE. This Cloud9 IDE can be accessed in two ways. One is by going through the AWS website and just signing up for the free usage of the tools, and you would be able to access the Cloud9 IDE. And the second way is that you can just use the IDE that is integrated in our systems. That is, once you have purchased this course, you will get access to the Cloud9 IDE for free. So let me just show you how to create environment, because to run your code, you first need to create an environment. So for creating the environment, you must remember one thing, that is which region you are using. Right now I'm using the Oregon region. So whenever you log in into your AWS, you make sure that you are switched to this particular region only, then only your environment would be visible. So here is this page. I have already created one environment, that is this Python sample environment, but I can create another environment. So I can just go to this create environment. I'm supposed to provide a name. Let's just provide data science as a simple name. Okay. And let's just actually provide the name of the library as well, that is the NumPy library. Okay. Description is totally optional. I'm going to skip it and click on next step. These are some of the environment settings. All these settings I'm just going to keep as default. Then click on next step. Here I'm required to just review my requirements. So yeah, I'm happy with all of this. Let us just click on create environment. After this, the AWS Cloud9 IDE is going to take some time to create your environment. And you can see the name of the environment has been assigned as data science _ numpy. So you need to wait for a few seconds till your environment is being created. So now our environment has been created successfully, and this is the page that you will see once your environment is created. Now what I'm gonna do is I'm just gonna zoom in a little bit. Yeah. Now first of all, what I'm gonna do is I'm just gonna install NumPy library. Okay, so basically what happens, if you are familiar with the basics of Python, you might know that we need to install some of the libraries. So I'm just gonna install the NumPy library. So let me just use sudo for this purpose. Why? Because I need the admin permissions to install it. So sudo pip3 install NumPy. Let's press enter and wait for a few seconds till the requirements have been satisfied. Yeah, so now it's downloading. So we need to wait for a few seconds till this download is complete. Yeah. So now the numpy library has been installed successfully, as you can see over here. Now what I'm going to do is I'm just going to create a new Python file. So you can go to file and new from template. Here we have this option of Python file. Let me just close this welcome tab, and what you need to do is, remember, once you have created your file, you just need to save it. So let's go to file and save it as let me just name it as file.py. Okay. Yeah. Now first of all, let us understand a basics of numpy. So numpy is a library that is open source. That means we can freely use it. It is used to work with arrays. Along with the arrays, we can work with algebra, the linear algebra, matrices, and Fourier transformations as well. If we talk about its history, so numpy was created in the year 2005 by Travis Oliphant. Numpy actually stands for numerical Python. So you must be wondering that why should we use numpy? So numpy has given us the ability to work with arrays. In normal Python, we can use lists to be treated as an arrays, but those are very slow. Numpy is faster than the lists in Python, and it has an array object called the nd array. It has a lot of built-in functions that could be used for that array, and whenever we are trying to work with the arrays in data science, then numpy is considered a very important library owing to its speed and resources. In numpy, the arrays are stored at one continuous place in the memory. Unlike the lists, so the processing and the accessing of the arrays is very fast. And this thing is called as the locality of reference. So locality of reference is one of the main reasons why numpy is considered a very fast library, or the numpy nd arrays are considered fast than lists. Numpy is a Python library, but it is written in C and C++ languages. If you want to learn more about numpy, you can go to the official documents of Python, or what you can do is you can just go to the GitHub repository where the numpy codebase is present. So let me just show you the link for the same. So this is the link where the codebase of this numpy library is present. You can see github.com/numpy/numpy. Here all of this code is present. You can access this code, right? Now let us come back to our code and let's see that how can we work with this numpy. So we have installed numpy. Let us now just import it. So import numpy as np. The first thing that we are going to do is create an array. So suppose you have a normal list. I have a list like list 1, and in this list I'm just going to create some random numbers, right? Like this. Okay. Now if I just want to convert this list into an nd array object, that is an object of numpy, what I can do is I can use a method that is known as the array method of this numpy library. So suppose I want to create an array arr, I can use np.array method, and in this I can pass this list 1 as a parameter. Now if we just try to print the types of both of them, let's first print the type of this list 1 and then print the type of this array arr, right? Let's just save the file and run it. Python file.py. So in the first case, this list 1 is treated as a list. In the second case, this array arr is treated as a numpy nd array. Okay, so this is how you can create or convert any kind of you can say object into an array of numpy. If you want to print its version, if you want to know which version of numpy you are using, you can just simply write version like this, and it will give you the current version of numpy that you are using. In my case, it is 1.20.1. Right, so now we have seen that how can we create an array object of numpy from a structure, from a sequence. However, if we don't have a sequence, what we can do is we can just directly create it as well. Let us create another array. So np.array, and in this I can just randomly provide some numbers. Okay, suppose I want to provide a tuple of numbers like 89, 78, 45, 23, 90, something like this. So what happens if we just copy this code and try to print its type over here with array2. So you see, again array2 is a numpy ND array. Now there are different types of arrays, that is there are different dimensions of arrays. So we have the different types of arrays. The first is the 0 dimension array that only contains a single element, right? Suppose we create an array like this. Instead of providing all these things, I can just provide a single digit like this. So now this array ARR2 is a 0 dimensional array. It is showing us as ND array, but it is a 0 dimensional array, right? So there are other dimensions as well. We will learn more about them in the next video. Hello everyone, welcome back to the data science tutorials. These tutorials are brought to you by ZDUP Technologies and Services. So in the previous video, we learned about the basics of numpy library in Python, and we also saw the 0 dimension array, right? So let me just comment out this code because we don't need it anymore, right? So here, this is the first array, that is ARR2. It is just having a single element. This is a 0 dimensional array. Next, we have a 1 dimensional array. ARR4 is a 2D array because it is containing these the elements in the form of rows and columns, the 2 dimensions. And then array 5 is a 3 dimensional array, right? So we have written all these arrays. Let me just indent it a little bit. Yeah. Now if we just try to run this code, let's just save it and run it. So you see, all these 4 are valid array types, right? But they have different dimensions. So how can we just check the number of dimensions of an array? For that, we have a method known as ndim method, right? So if we just write print the name of the array, that is array2.ndim, it will give us the number of the dimensions of this particular array. So what I'm going to do is I'm just going to copy and paste this method for each and every array. 5, array number 4, and array number 3. Let's just save it and run it. Now it is giving me the number of dimensions. Array 2 is a 0 dimension array, array 3 is a 1 dimension array, and so on. Also, what you can do is while specifying the array, you can also specify the number of the dimensions, and that array would be changed to that particular dimension. Suppose in the case of array 3, I have specified this array, and with a comma I specify its dimensions with this ndim parameter to be like 6. Then what happens? Let's save it and run it. Okay, that's giving me some kind of an error. Actually, there's a typo over here, like this. Okay, so now you can see this array array 3 is now having 6 dimensions, right? So you must remember what is the spelling, otherwise it will throw you an error. Now this is working with the array elements, that is working with the dimensions. If you want to work with the array elements, you can simply just index them. Suppose, let me just remove this from here because I'm just going to treat it with as a one-dimensional array. The highest dimension that you must be working with is a 2-dimension, and 3 dimensions in some exception cases, but not higher than that. Okay, so here if I want to access some elements, suppose I want to access the element of this 3rd dimension array, then how can I do that? I need to specify 3 things. First is I want to select this particular parenthesis or this particular parenthesis, right? So I want to suppose display this 11, then I will go the first dimension as 1. So the first dimension would be 1, and the second dimension would be, so let me just put a comma, second dimension would be like again 1, because in this 0 and 1, this second parenthesis is what I want to access, so second dimension is also going to be 1, and the third dimension, that is again is going to be 1, right? So put a comma and 1. Let's just save it and run it. So you can see 11 is accessed, right? However, if you just want to access some element of the 2-dimensional array, what you can do is you need to specify 2 dimensions. Suppose I want to access this 5, or let's access this 6. So firstly it is going to be the row number 1, then the element number 2. So 1 comma 2 will display 6. Similarly, if you're just trying to print the array of 1 dimension, any element of the 1 dimension, you can just specify a single dimension. I want 98, so its index is 0, 1, 2, 3. So let me just specify 3. Let's just save it and run it. So you can see 11, 6 and 98. The array elements are accessible. If you just want to access any element of the 0-dimensional array, you can simply just print the 0-dimensional array like this. And you see its element is printed. You don't need to specify anything for the 0-dimensional arrays, right? Now we have negative indexing as well. That is, if you're talking about 1D array, so -1 will refer to 28, -2 will refer to 22, -3 will refer to 98, -4 will refer to 12, and so on. So let's just write -3 to see what happens over here, like this. Okay, so you see -3 is again gonna give us 98. Let's just change it to -4, let's say. So it's going to give us the different element, that is 12. If you just go up and check, yeah, 12 is what is referred to by -4. So negative indexing of the array elements is also possible. If you just try to access any of the array elements, that is out of the bounds, right? If I try to access the array at the index 10, while 10 elements are not present in this array, ARR 3, then in that case we will be thrown an error, that is the index error. So you must be very sure that whatever index you have provided is within the range of the array elements, right? Next is array slicing. If you want to slice the array, you have to pass the starting and the ending index with an optional step value. Like I want 23, 12 and 98. So what can I do is I can slice it from 0 to 0, 1, 2, 3, 0 to 3. So what will happen in the case of this array 3? Let's just print array 3 being sliced from 0, put a colon, 3, right? Let's just run it. So 78, 23 and 12 are printed. If you pass a step value, let's just pass 0 till 5 and the step value of 2. In this case, what will happen? We will get the step value of 2. That means one element would be skipped. U3. This 23 is skipped, this 98 is skipped as well. The first index is exclusive, the second index is inclusive. Like this, you can work with just any kind of array and also use the negative indexing if you want. Suppose you want to slice a 2D array. Let me just show you an example of that as well. So ARR4 is our 2D array. If you just want to slice it, you must know which row you want to slice. So I want to slice this first row. That means 0 is going to be the row number. I want 2 and 3. That means from the beginning till the very end, that means 0 till 2 is going to be the index. So 0th row, that's what you're going to select, and 0 till 2 is going to be the index that I want to slice. So see, 1, 2 is printed. Actually, Okay. Now you can also specify the step value in it if you want. So that is about slicing of the arrays, right? Now we know we can just create an array of any data type, right? But right now we have created all the integer arrays. So basically, if you just want to check the data type of an array, then what you can do is you have a method called dtype. You can just use this method and it will give you the data type of the array elements. Like you can see int 64. If we create a new array, let's say arr 6, and in this we are just gonna store some of the, you can say, string elements, right? Hello, hola, and hi. So basically it's salutations in Spanish and English. And if we just try to print the type or the data type of this array using this dtype property, then it will give me the data type as string, or you can see like this. Okay. Actually what we can do is we can just create it in single quotes, I think. Save it and run it. So yeah, it is giving me like this. So that must be the data type, right? Okay. If I just change it to a list, then what happens? Yeah, so it is giving me this u5. So basically this is used to refer to a string, as you can see. Whether you just write it with double quotes or single quotes, this is what the data type of the string is. It's not going to change for double or the single quotes, right? So that's all for this video. In the next video we will continue with numpy library. Hello everyone, welcome back to the data science tutorials. These tutorials are brought to you by Untitled Technologies and Services. Let us explore more about the numpy library in Python. So basically we have seen that how can we get the data type of any array in Python using the numpy library. Now while creating an array, suppose I want to create a new array arr7 and I want to be it of specific data type, right? So what can I do is I can just create a list of numbers, or yeah, let me just give some numbers like 65, 67, 78 and 95, like this. Okay, so these are some of the random numbers. Now what will this do? It will just create an array of integers. But if I want it to be of different data type, what can I do is I can specify the particular data type, right? I can just use this dtype as a parameter, and in it I can specify its type, right? Suppose I wrote s over here. This means this data type is going to be of string. Its data type is going to be of string. Now if I just try to print the data type of this array, that is arr7.dtype, then what happens? Let's just save it and run it. You see we are getting its data type as a string. So this is how we can just select the data type. Now if you just want to convert it to a particular data type, that is, once you have created an array and you want to just convert it to a particular data type, then what you can do. So for that purpose, what I'm going to do is I'm just going to consider this array, that is arr7, which is containing integers but is treated as a string array. I'm just going to create new a7, just a random variable, and in this what I'm going to do is write arr7 dot as type. So as type is again a method that is going to convert your array to the particular type you have specified. I'm going to specify small I for integer because I just want to convert this array to an integer type, right? Okay, so what we can do is we can just copy this code and paste it to just display the data type of this new array, that is new A7 that we have created. So you see now its size is int 32. So that's how you can work with the arrays and the data types. You can convert it to any data type you want. Now, what if you want to create a copy of an array? How can you do that? So we have the copy method with which we can create a copy of an array. Suppose this is the array new A7 whose copy you want to create. So cpy A7, let's just create a new variable. To create its copy, what we want to do is just provide the name of the array, put a dot and use this copy method, right? So this copy method is gonna create a copy of this array, right? If we just try to print both the arrays, that is print new A7 and print this cpy A7, then what will happen? Both of these arrays would be printed, which are the exact copy of one another. Now, what will this copy method do? It just creates two copies of the arrays, right? Now, if we make any changes to the cpy array or this new array, new A7 array, then those changes would not be reflected in one another, right? Like suppose I come to this cpy A7 and I just make a few changes, right? Like in the 0th index, cpy A7's 0th index, instead of 65, I'm just gonna store 90. Let me just save this and run it. So you can see this new A7 remained the same with the 65, but only the cpy A7 changed to 90. That means two copies of the array are created. There is another method that is known as the view method that is also going to create the copies of the array. That is view A7. In this, I'm just going to create a view of this new 7 array with the help of this view method. Okay. So it's also going to create a copy of this array. So if I just try to print this view A7 array, then what will happen? You see, both of these arrays are also identical. This is new A7 and this is view A7. But the difference is that whatever changes you make into the array once it's been created as a view, those changes would be reflected in one another arrays, right? Suppose I make a change after creating the view, I make a change to my new A7 array. At the second index, instead of 78, I'm just gonna use 23. Let me just save it and run it. Then you see in this new A7 array, 23 was stored. Similarly, in this view A7 array also, this 23 was stored. So this is the main difference between this new this copy and the view methods that you must keep in mind every time, right? Now, we have created these arrays. This new A7 array was the base array, right? But this copy A7 and view 7 have been created from this array. So if you want to just check that from which array a particular array is created, then what you can do is you can just use the base method or the base property. This is this base property that's going to give you the base array with which it's been created. So right now you can see there is no base array because we have made some changes into this array, right? But if we just remove this piece of code, then I believe it should work. So yeah, I have removed that line and okay, not that one. I just want to remove this line, right? So save it and run it. Okay, I think I should remove this one also. So yeah, you can see that in the case of copy, we are not getting the base array. Every time we are getting the none. But if we just try to print it for this view array, that is view A7 dot base, then what happens? We would be able to get the base array. Because in the case of view array, the base is preserved, it's the same. The copy returns none, that means a copy has been created, that's why the array has been changed. Okay, so that is about the basis. Now if you just want to know the shape of the array, now what is the shape? Shape is how many elements are stored in each dimension. Okay, so we have these different arrays. Let us just get rid of this copy and the view arrays, or what we can do is we can just get these arrays right now. Okay, so we are gonna work with them. So let's just remove them from here. Actually, what I'm gonna do is just copy them and comment them from here. All this previous code, I'm gonna comment it out. Right now, let's just paste this arrays. Right, so we know what array we are working with. We have all these arrays, right? So if we just want to just print the shape of the array, then what happens? Suppose we print the shape of this array of 0 dimensions, right? So the shape method is basically going to give me that in each dimension how many elements are stored, right? So let me just copy and paste the code and change it for each array, like array 2, array 3, array 4 and array 5. Let's just save it and run it. So you can see, firstly we are having nothing, that means just the one element. Then we are having 6, so there is only one dimension in which 6 elements are present. Then we are having 3, which means there are 3 rows. The first parameter is going to tell you the number of rows. That means there are 3 rows, and in each row there are 3 elements stored, right? So when you multiply them, you get the total number of elements present in the array, that is 9 in this case. In the case of 3-dimensional array, the first dimension tells us the presence of parentheses. Right now 2 parentheses are present, so 2. Then we have 2 rows in each parentheses, that's why 2. And then we have 3 elements in each parentheses, that's 3. So if we try to check the number of elements, that's 3 into 2 into 2, which gives 12, which is exactly the number of elements we are having. Okay. Now this is actually the shape is in the form of a tuple. So this is going to represent that in each dimension how many arrays are present. Now if you just want to reshape the arrays, then how can you do that? Okay, so while reshaping, you need to just remember one thing, that is how many elements are present in the original array. You should provide the parameters according to that only, right? If we take an example of this 1D array and try to reshape it, so that means 6 elements are there, so we should create a shape that should only contain 6 elements. So how will we do that? This we will see in the next video. Hello everyone, welcome back to the data science tutorials. These tutorials are brought to you by ZDUP Technologies and Services. In this video, we are going to see how to reshape our arrays. So this is a 1D array containing 6 elements. While reshaping, we must understand that whatever dimensions we are providing, that must be like having 6 elements. Okay, so let's just create a new array NARR3 and try to reshape this array using this reshape method, right? So we can just provide how many dimensions we want. Suppose I want to reshape it into a 2-dimensional array. That means I want to specify 2 dimensions or 2 numbers that are comma separated values, right? So since there are 6 elements, what can I do is I can specify either 6 into 1 or 1 into 6, which is the current dimension, or 2 into 3 and 3 into 2. Okay, so there are these 2 ways. So if I just specify 3 comma 2, let's just save it, print the array, that is NARR3, and print the shape of this array. So NARR3 dot shape. Okay, save it and run it. So you see it's been successfully changed into an array, a 2-dimensional array that is containing 3 rows, and each row is gonna have 2 elements. So 3 rows, 78, 23, 12, 98 and 22, 28, each containing 2 elements each. And 3 comma 2 is its shape. If I just change it a little bit, that is I want 2 rows each containing 3 elements, right? So that's also possible. So yeah, that's also possible. Okay, yeah. Now if I just try to change it to say 2 rows each containing 5 elements, this means if I'm shaping it to this, then its total number of elements are gonna be 10 elements, but we are providing only 6 elements. So what will happen in this case? An error would be created that we cannot reshape an array whose size is 6 into this particular shape. Okay, so you must remember that whenever you are reshaping the array, you should provide the dimensions that we have given. Okay, now we have reshaped this array. Let's just check if it is having a base or not. So what we can do is we can just copy this and paste it, dot base. Okay, run it. So yeah, it is having a base. That means this new array that we have created through the reshape method always returns the view, not the copy. So it returns the view, not the copy. Okay, now what we can do is we can also give this unknown dimension, right? Like we can give that we can specify that we want these number of rows, but whatever the number of elements is, that numpy would figure out on its own. Suppose you want 3 rows over here and you don't know how many elements are going to be there, so you can just specify a simple -1. Then what will it do? Save it and run it. It has automatically assigned it to 2 elements each, right? So this is the dimension, this unknown dimension. Okay, so this -1 is known as an unknown dimension. You can also flatten the arrays. That means if there is a multi-dimensional array, suppose there is a 2D array, let me just copy my 2D array here and paste it here. I can flatten it, that is I can just reshape it into a dimension of 1. That means in a 1D array. So let me just remove all these comments. So for this, what can I do is I can just write print. I'm just right click on a reshape it, error4.reshape. I don't want to specify anything, so what can I do is I can give the unknown dimension as -1. So actually there is some kind of an error. That's on line 129, right? So there is some kind of an indent, that's why we were getting the error. Yeah, so you see it's been converted into 1D array. This 2D array has been converted into 1D array. Since I had not specified any dimension, I'd given unknown dimension, so it's given me like this. Okay, now how can we iterate through the arrays? For this we can use a for loop, or basically the loop that we want. Okay, suppose I want to iterate through this 1D array, so I can use for x in the name of the array is error3. I can simply print the individual elements which would be stored in x, right? Let's just save it and run it. So yeah, all these individual elements are printed, one in each line. Now if you want to iterate through a 2D array, then what do you need to do? We can use a for loop, like for x in the name of the array is error4, and what can I do is I can just simply print this x, right? Let's just save it and run it. So what will it do? It will give me these elements like this in a row wise fashion. That means 1 2 3 in one row, 4 5 6 in one row, 7 8 9 in one row. However, if you want to access the individual elements, then what you can do is you can just write a nested loop like this. Okay, and then print this statement. So when you just write something like this, then what will happen? Actually, not x, we want to print y. Okay, so when you write this statement, what will happen? You see the individual elements are printed. So there are two ways of printing a 2D array. One is the individual elements, and the other is in a row wise fashion. And if we just copy this and paste this, for array 4, it's going to print the array elements in a row wise fashion. Similarly, you can work with arrays of any dimensions, and that's what it's going to give you. Let's suppose we have a 3D array. Actually, we have a 3D array, this error5. So let me just quickly show you how can we iterate through it as well. Okay. So here you see I have iterated through the 3D array. That is, it's gonna give me the first dimension. In first dimension there are two other dimensions where we are having single elements. If you want to iterate through individual elements, you're gonna use 3 for loops. Okay, so that is iterating through the arrays. There is another way through which you can iterate through the arrays, and that is through iter method. Okay, now let's just use it on this 3D array only. Suppose we have this method that is called iter method. Now using this method we can specify the array, that is arr5, right, and save it. And now if we just run it, so you see ultimately instead of using the 3 loops, if we just use this iter method, it's gonna give me the individual elements like this. Okay, so either you can use multiple loops, or if you want to access the individual elements, you can just use this particular method. With this you can also specify the steps that you want to give or you want to proceed with. Like right now default value is gonna be like 1, giving us each element. If you don't want every element, you want some other elements, you can just provide that as well with a step size. Okay, right, we have another method, that is enumerate method. Let's just try that as well on this 2D array. So instead of writing it like this, I'm just going to write np.nd enumerate method and pass this arr4 over here. Let's just save it and run it. So what will it do? It will just give me the sequence of each element, like 0 0 at the 0th row. In 0th column we have 1, in the 0th row first column we have 2, in the 0th row second column we have 3. So this method is going to give me the position of the elements as well, right? So you can use it in any dimension of arrays. Now if you are trying to concatenate or join the arrays, how can you do that? Let us just comment this code all out and try to work with it. Okay, so this is the code, that is A is one array, A1 is another array. We are using the concatenate method, giving 2 arguments, so and concatenating it into a new array A2. Let's just print A2. So yeah, there is some kind of an error. Let me just check it. That's because we need 2 parentheses over here, right? Let's just save it and run it. So you can see both these arrays are concatenated. So that's all for this video. Thanks for watching. Hello everyone, welcome back to the data science tutorials. These tutorials are brought to you by ZDUP Technologies and Services. In the previous video we saw that how can we concatenate 2 arrays, right? Now with the concatenate method we have an option of access, right? So with this help of access we can specify a particular number, and that would be the dimension of the resultant array, right? So here what we are doing, that was the code from the previous video where we have concatenated A and A1, but now we have provided access as 2. So if we just try to run it, actually let's just save it and then try to run it. So you can see I'm getting an error. Why is that? Because access should always be in a lesser dimension than that of the original array, right? We had the original arrays as first dimension, so the access parameter we can pass must be less than equal to or less than 1. Okay, it can be any dimension but it should be less than 1, right? So if we just provide 0, then in that case what happens? You see there is no error. Now we have converted this array into an array of 0 dimensions, right? However, if we just try to just do the same task, we can just comment out this code. Here what we have done is we have splitted this array into 2 dimensions. That means A is a 2D array, A1 is also a 2D array. That means A2 would be a 2D array, but we have changed its access to 1. That means what will happen if we just try to save it and run it, then what will happen? We will get a 1D array from this 2D arrays. Okay, so basically this is how we can work with the access method. Now there is another function known as the stack function, which could be used to again join the arrays. It is same as the concatenation. The difference is that the stacking is done along a new axis. That means if we concatenate two 1D arrays along the second axis, then it would stack them one on the top of the other. Okay, and if no access is passed, it's going to take it as 0. So let's just try that. Remove this access method, and instead of concatenate, let's just write the stack method. Save it and run it. So now we are having this 2D array. If you just want, you can just print its dimension as well, like this. Okay, that is just a second. So we provide this ending method, and you can see its dimension is 3 dimensions. Okay, now there are two ways in which we can do stacking. One is through the rows and the other is through the columns, right? So let us just get rid of this code. Let's comment it out. In the array A3, we are just gonna stack it using the rows. So for that we have a method called hstack. That's gonna take the two arrays, that is A and A1. Let's just print this A3, and if we just try to stack along a column, then we have the other function as vstack. So let's just write that as well and try to compare the difference between the two. So let's vertically stack A and A1 and print the corresponding A3. Right, let's just save it and run it here. So you can see we are getting actually somewhat similar arrays in the case of the hstack and the vstack, that is along the rows and the columns. However, if we just change it to a single dimension, that is instead of the 2 dimension, if we are having just the single dimension arrays, then it would be able to show you the difference. So yeah, let's just now save it and run it. Okay, that's some kind of an error. And that was a missing comma. Yeah, so with the help of hstack, we are getting this whole array like this, and in the case of vertical stack, we are getting it like this. That is, if we just try to compare its dimensions, so let's use this ending function. The horizontal stacking is gonna give me the first dimension, the vertical stacking gives me 2 dimensions, right? However, if I just try to make a few changes in my code, that is, if I just go back to my 2D array like this, here you see I was printing A3 both the ways. If I just try to print A4 on the second line, then you can see the difference over here as well. In the case of hstack, we are getting a 2-dimensional array, but in the other case, we are getting the stacking done with the help of columns. If you just compare their dimensions using this method or this property, here you can see that both of them are having 2 dimensions, but here this row, this whole row is stacked on this row in the case of hstack, and this whole row is stacked on this row. But in the case of vstack or the column stack, this row is treated as one row, this is second, this as third, and this as fourth row. So this is how the stacking occurs in the case of an array. Then we have another method, that is the dstack method, that is used to stack with the help of the depths. So if we just write it quickly, dstack arrays A and A1, and then try to print the array A5. Let's just save it and run it. So you see it does it on the basis of depth, that is 78, 61, 23, 23, 12, 45 in 1, then 9823, 2254, and 2899 in 1. So this is the stacking on the basis of depth. So there are 3 ways in which we can stack the arrays: through horizontal stacking, vertical stacking, and on the basis of the depth stacking. Now if you want to split the arrays, how can you split it? Let me just comment out this whole code and create a new array. That's going to be a 1D array. Okay, so let me just create an array A, and it's going to be a 1D array. So some numbers would be given. Now what will the split function do? It will just split the array. Okay, we need to specify that in how many parts you want to split the array. So let us directly just print the array. That is, the method is np.array_split. Okay, it requires 2 parameters. First is the array, and second is in how many parts you want to just split this array. So I provide 3. That is, in 3 parts I want to split this array. Let's just save it and run it. So you see 3 arrays have been returned. One contains 2 elements, other contain 2, and the other contains 2. There were 6 elements, so they have been equally splitted. Now if we just specify, let's say 5 over here. Okay, so that is not a standard for splitting. Then what it does, firstly it splits this first number into 2, then all the rest of the numbers into 1 arrays, right? So basically it will split according to the number that you have provided. Now if you want to split 2D arrays, then how can you split it? So I'm just gonna uncomment this. That means this A1 is what I'm just gonna keep as a 2D array. So let's just copy this here. And paste it. Let's see how can we split this 2D array. So to split this 2D array into 2D arrays, what we do is simply just write this code only. Okay, just copy it and paste it here. We need to specify how many parts we want to split it. So let's just specify as 2. Then what happens? You see 2 arrays have been created. Actually that's A1 that we need to provide. Okay, so now you see 2 arrays have been created, 1 for each row. However, if we split it into 3 parts, then what happens? 3 arrays have been created, 2 with the contents, 1 is a array with no elements, right? And when this kind of situation occurs, it gives you the shape and the data type of that array as well. Okay, so that's how the split function works with arrays. Now split function also has this horizontal split and vertical split. This we will see in the next video. That's all for this video. Everyone, welcome back to the data science tutorials. These tutorials are brought to you by ZDUP Technologies and Services. So in the previous video we learned about the array split function. Right now we are going to take a look at another, you can say, split function that is known as the H split function. So H split is very similar to the H stack function that we have already seen. So let's just see what the H split function is gonna do. So I'm just gonna create another print statement, and in this I'm gonna use this H split function. So np.h split, we need to provide the array H, that is A1, and in how many parts we want to split. So let's just provide 2 parts. Let's just save it and run it. So yeah, here we are getting an error on line number 198, that is over here. Okay, so let me just check. So yeah, 2 was not dividing the array into equal parts. That is why we have chosen a number 3 that is going to split this array horizontally into 3 equal parts, right? So this is going to split the array in rows. As you can see, we have got one array that is containing the elements 67 and 23. Other is containing this 23 and 54. The last array is containing 45 and 99. That is this last elements, right? So this is what we have done, splitted the array into 3 parts, right? Similarly, we have this vsplit function. So if we just want to copy and paste this code, and instead of hsplit, let us write vsplit. This is very similar to vertical stacking or vstack. That is, it is going to split the arrays along the columns, right? So let's just provide the code, save it and run it. Here it's divided into 2 equal parts. That is, first this row and the second this row. So these are some of the splitting functions. These are some of the ways in which we can split the arrays, right? After splitting the arrays, we have some methods that help us to search through the arrays. Okay, so for this, what I'm gonna do is first of all, I'm just gonna comment out this code, and this is my 1D array. Okay, so I'm just going to add some more elements to this array, some random elements like this. Okay, so the first method that I have for searching the arrays is known as the where method. So this where method takes a particular value and just returns that at what indexes that value is present, right? So if we just write directly in the print statement, this array a dot where, and then we provide the index. Actually, we should use np.where and array name, that is a, double equals what number you want to search, 78, like this. Okay, let's just save it and run it. So we are getting 1, 6 and 10. So if you see, in the first index we are getting 78, then on the 6th index, and then on the 10th index. Similarly, we have repeated this number 56. So let us just check for 56 as well. And let's just save it and run it. So we are getting 56 on index 3 and 7. Okay, so this is what the where is used for. Actually, using the where, we can also find the particular condition. Like, we can apply condition over the arrays, individual array elements, and display the indexes where the conditions are met. Suppose I want to just show the odd elements in this array. So what can I do is, let me just copy this and paste it here. With the where clause, I can provide a condition, the condition to check odd elements, and that is a mod 2 is not equal to 0. Right, so this is a condition that I have provided. If I just save it and run it, then I'm getting some indexes, that is 0, 5 and 8. If you see, in the 0th index we have got an odd number, 87 is odd number, and then 33 is odd number. So whichever indexes match these conditions, they are being shown over here, right? Now we have another method that is known as search sorted method, that is used to perform a search on the array and return the index where that particular element is found. Okay, so suppose we just try to print it again, that is np.search sorted, like this, and it requires 2 arguments. One is the array, so a is our array, and what element you want to search. Suppose we want to search for 78, like this. Okay, let's just save it and run it. So it is giving us 4 as the index, which is not correct. Why? because the search sorted method requires that the array must be in sorted order, only then it would be able to search through it, right? So what we can do is we can just create a new array. Let's just name it as b np.array, and in it I'm just going to write some sorted elements like this. Okay, now in this b I want to search for 11, so b comma 11. Let's just save it and run it. So you can see I'm getting the correct output, and that is at the second position. So you must make sure that every time you are trying to search for an element using the search sorted method, the array must be always in the sorted order. Okay, next we have the side parameter of this search sorted array. What will it do? It will just change the order in which the elements are searched. Right now what we are doing is we are searching or the searching of the elements starts from the left hand side, and we are getting 9, 10 and 11 printed. Okay, that means the second index is printed. But if we just want the searching to start from this right side, so what we can do is we can just provide a side parameter, and this side parameter I can provide the value as right. Let's just save it and run it. So here you can see we are getting the value with respect to right, that is the rightmost index. Okay, that is where it is found from the right hand side. Okay, if you want to search for multiple values, then also you can do that. Let me just provide that as well. So since we have provided a tuple, so we need to provide a tuple of values. That means we want to search for 10 and we want to search for 11. So we can just do that. So 10 is present at the first index, 11 is present at the second index. Okay, now if you want to sort the arrays, now what is sorting? As you might have understood from here, that sorting is basically to arrange the elements in a specific order, right? That is either in the ascending order or either in the descending order. So how can we do that? For this we have the sort method of the array. Okay, suppose this A array is unsorted. If we just try to sort it, how can we sort it? So we use the numpy in method, that is the sort method, and provide the array which we want to sort, which is A in our case. So we provide this array, and you see it has sorted all the elements in the ascending order. This is the by default method in which the arrays are sorted. Okay, similarly any dimension of an array could be sorted, whether it is a 2D array, whether it is a 1D array, anything. Okay, now if you want to just filter the arrays, like you want to get some elements out of an existing array and create a new array out of them, right? So this is known as the process of filtering. So how can we filter the arrays, right? So this is something that we will see in the next video, where we will be seeing the whole process of filtering the array. That's all for this video, and thanks for watching.